According to Industry Arc, the data center industry is projected to grow to $418 billion by 2030. Data centers face rising energy costs and overheating due to inefficient cooling methods. InCooling offers an innovative two-phase cooling method that effectively manages heat while reducing energy consumption. Rudie, what is the state of the art in data center cooling today, and how is InCooling revolutionizing it?
Over the last 10 years, we see water cooling coming in. So what we really focus on is an easy to implement solution that's all housed inside the server itself. So we have basically a chip conditioning system inside the server that can allow you to cool down the chip when it's needed. So basically a mini air conditioner for your CPU.
Indeed, with water circulating around electronics and integrated circuits, a lot of bad things can happen. But there's also a cost issue with water cooling. So when you think about the InCooling solution, cost and form factor versus a water cooling and all the infrastructure around it, how does it compare?
So when you come to hardware, you will have to invest in something state of the art. It of course will cost money. But on the long term, you won't have to change your knowledge. You won't have to change your people. And the training of people right now is really a big challenge. So there you will immediately save money. And then over the long term, this will keep you flexible, not stuck in one of the ecosystems that are currently out there. Our system works in any data center all around the world, so you're not locked in for future expensive upgrades.
How does the architecture look when it's going inside a server? This requires integration with vendors. So how do you go about achieving that as a new and growth company?
Our system really routes around their solution. There will be a cold plate on the chip. Then there's some sort of compressor or pump and a radiator. And this can be configured as needed. So we're very, very flexible there.
How much of a performance improvement have you been able to achieve with an existing deployment?
One of our most proud innovations there is really pushing the CPUs. So before we had a 10,000 euro chip and a 40 euro cold plate. Now we are really putting in the right technology on the cooling and seeing the performance go really fast. If you look at performance itself, up to 40% increase in application performance.
What are the elements that you have to see in a data center to get InCooling to work in terms of power and other infrastructure and training?
So if you look at the upfront requirements for us, we need to know that there's enough power available to get to the racks. So normally you have a data center, you have your cooling system on one power grid, and you have your IT on the other. Now all of a sudden they become the same. So we need to be able...
Because you're physically inside the server chassis.
Correct. The cooling is now inside the servers. So this is quite a mindset shift also on tracking of power consumption, etc.
Right.
All of a sudden it's shifting to the IT load. And there we have to definitely help our customers split the data and get that correct view.
Existing data power infrastructure really does have those things bifurcated between cooling and IT.
Yes.
And so is there a need to re-architect in any way existing data center electrical infrastructure to make this work?
Definitely. So you do look at a new architecture on the internal side, but this is a matter of cables. Electricity cables are much easier to put down than water cables or water tubes. The real challenge is the new hardware that are coming in is also doing the same trend. So new cables is already required. We need to get new cables in for the new hardware.
Because power consumption is going up.
Correct. We're talking about 4, 5, 6 times compared to 10 years ago.
In terms of the intellectual property or patent moat around InCooling, what have you been able to achieve in this regard? How do you prevent copycats from coming in quickly?
So on one side, we have this real advantage when it comes to technology understanding of the chips. We are not glorified plumbers. We are real technologists at heart. So there, we're trying to really be quite different than other cooling companies. On the other side, we are hardware agnostic. Most of the cooling competitors are actually part of a Dell or a Gigabyte or a Lenovo. We are free to go where we want. So this is quite unique. And finally, of course, we have our IP, and we're going to defend it tooth and nail, but that's of course an expensive and long story.
And the IP is a two-phase cooling solution. What are the components of the cooling solution, and what do you mean by two-phase?
So the two-phase is really about pumping a liquid to a chip. The chip heats the liquid up, and it converts into a vapor. It boils inside this system, and that extracts an immense amount of heat. By controlling the pressure of this boiling apparatus, we can control the temperature exactly. Similar to boiling water here or on a mountain, the temperature will be slightly different.
Different.
And this is where really the secret sauce is, controlling the phase change.